Welcome to Sigma Tech Consult. Today we shall be talking about lines, angles, and circles. By the end of this lesson, you should be able to define line, list different types of line and their uses, define angle, state different types of angles, highlight different ways of drawing angles. You should also be able to define a circle and explain different parts of a circle. Okay, in engineering drawing or in technical drawing, the language of line is what is used for communication. So we cannot do in engineering without lines. Hence, the need for this study we want to do now. Okay, so what exactly do we mean when we say a line? What does it mean? A line is simply a narrow path made between 2 points in a surface. So if we have a point joined to a point, a line is formed. So when we have this narrow line between 2 points, we say a line is drawn. So these lines are of different types. We have different types of line. We have a line we call the continuous thick line. We have the continuous thin line, the short dashes, the thin long chain, the thick long chain, the thin continuous wavy line, the thin continuous line with an arrowhead, the rule line and short zigzag. All these are different types of lines that we have, and they are used for different things in technical drawing and information. All right, so we're going to examine these lines and what they are used for. For example, a thick continuous line is especially used for visible outlines on borders. After your construction or your drawing, you have to use a bold line or a thick continuous line to show the outlines of the drawing. We're going to do that when we start the technical drawing or drawing proper. You're going to see how the outline is done. After your constructing with a thin line, then you use the thick lines to show the outline of the major thing you are drawing, or anything you want to produce. Let's say you want to produce the isometric drawing of a special shape then we're going to use a thick line to show the outlines. Okay, we also have another type of line we call the continuous thin line. This continuous thin line, like you see on the board here, is specifically used for construction lines. They are used for showing dimensions, dimension line, projection, the leader lines, and sectional cuts. All these are things we use the continuous thin line for. You want to show your projections, you want to show the drawing lines or construction line, as the case may be. You want to show the dimensioning of lines. We use the thin continuous line or continuous thin line to show that. Okay, we also have the short dashes. Okay, short dashes, they are specially used. They are lines, but we use them to show hidden details in shapes. For example, you are making an orthographic drawing of certain shapes, and there are areas in that shape that are hidden. We use these short dashes to show that this detail here was not captured, in the way you are seeing it. It is there, but we cannot see. So we use the short dashes to show hidden details of a particular shape that you are showing its orthographic projections. All right, we also have the thin long chain, right? In this thin long chain, we use them basically for center lines. We use them for pitch circles and path lines used in indicating movements. Basically, that's what we use this kind of line to do. We also have the thick long chain. Basically, this is used for cutting sections and viewing planes. We use this line for cutting sections in case you want to show sections. We make use of this thick line. The ruled line and short zigzag, they are specially used for long breaks. When you want to show long breaks, we make use of this line to show that. We also have another line, a continuous wavy line, a line that is wavy like this. Specifically, we use them to show boundaries. or a short break lines. We use them to show that the continuous line is important. You know what each of these lines are used for, because in technical drawing or in engineering drawing, so to say, anyone you know it with, you will be making use of these lines to show different things or to do different constructions in the course of your activity in basic technology. Okay, we also have the thin continuous line with arrowheads. We use them to show, also use them as dimension lines. We use them to show dimensions of shapes, the length and breadth of shapes. We use these lines to show that. Now, a line can also be divided into two equal parts. Whenever a line is divided into two equal parts, we'll say that line has been bisected. So to bisect a line simply means to divide a line into two equal parts. To do that, we require not much a special skill to do that. It's just for you to have a compass. All you need to do is that, for example, using the center A here, using this A here as your center, just extend the radius of your compass such that it is beyond the center of this line AB, like you see here. You know, make an arc over and below this line. Same thing you do here, using point B here as a center. That simply means let the tip of your compass be at point B. That's the meaning of the word I said, using point B as a center. It means put the tip of your compass at point B, and also ensure that you use the same radius as you used in A. Now, make an arc above the line and make an arc below the line this way. When such is done, the point of intersection of the two arcs up and down, join them. Once that is done, you have divided this line into two equal parts. I need you to see what I'm talking about. Let's say we have this line here. So all you need to do is to make an arc above and below. Then point of intersection of the arc, you know, join the two lines. That gives you the a bisector of that line, the perpendicular. You see that line AB has been divided into two equal parts. We call it bisection of lines. When we start our major constructions, there are things we're going to talk about lines, how you divide lines into different portions. We're going to talk about that, proportions. We're going to talk about that when we start our construction properly. So, okay, I just need to give you this information about lines so that it will prepare you for the next class that is coming. Now, angles. Angles are formed when two lines meet at a point. Whenever we have two lines meet each other, we'll say an angle is formed. That is why the angle between two parallel lines is 0, because parallel lines can never meet each other, right? So when we say the angle between parallel lines, we're simply telling you that parallel lines cannot meet. Therefore, no angle is formed. That's the implication. When you hear that angle between two parallel lines is 0, it means they cannot meet. So where two lines meet, an angle is formed at that point. We have different types of angles. We have an angle we call acute angle. We have obtuse angle. We have reflex angle. We have the right angle. We have the straight line angle, the complementary angle, and the supplementary angle. Permit me to tell you the meaning of each of these angles and show you pictures to help you understand it properly. Now, acute angle is an angle that is less than 90 degrees. All right? It's less than 90 degrees. So we call it acute angle, just like your greater than hand and less than hand. Angle like this is called acute angle. We also have an angle we call obtuse angle, an angle that is greater than 90 degrees, but not up to 180 degrees, is called an obtuse angle. And a reflex angle is an angle that is greater than 180 degrees, but not up to 360 degrees. When we have 360 degrees for an angle, a revolution is made. That means the body has turned around the circle. Now, we also have a straight line angle, angle between angle and a straight line, which is equal to 180 degrees. We also have complementary angle. Complementary angle is just two angles that sum to 90 degrees. For example, 45 and the 45, both of them added together, they are called complementary angles. The sum of these two angles equals 90 degrees. We also have an angle we call supplementary angle. This way, the sum of these angles, whether one or two or three angles, when they sum to 180 degrees, we'll say that such an angle is supplementary. All right. Now, this is an obtuse angle here. It's greater than 90 degrees, but less than 180 degrees. Same thing as an acute angle ranging from greater than 0. Like I said, 0 means no angle. Yeah, that's what it is. But it's less than 90 degrees, like we'll see here. Angle made by line OA and line OB. Both of them meet at point A, point O. So they form an angle there, and that angle is acute angle. We have a reflex angle here, something I've said before, greater than 180 and less than 360 degrees. Now, we also want to talk about a circle. A circle is a figure formed by closed curved lines on which every point is at an equal distance from the center. Every point is equidistant from the center. That means from this center of a circle here, all distances from this center to the circumference of this circle, they are equal. And this line here you're seeing is called a radius. Now, we also have other properties or parts of the circle we want to talk about. All right. Now, the line that runs from the circumference, a point in the circumference, to another point in the circumference through the center of the circle is called a diameter. A diameter divides a circle into two equal parts, and we call one part a semicircle and we call the other part a semicircle. Now, we also have another line here that runs from a point on the circumference to another point, but this time it's not dividing the circle into two equal parts, or you can say it did not run through the center of the circle, and we'll call such line a chord. A chord divides a circle into major segments and minor segments. Now, you can also see from here too, we have a line that runs externally or exteriorly from the circle, but touching the circle at a point in the circumference. We call such a line a tangent. We also have a line that runs across the circle and extends to the exterior part or external part of the circle. We call such line a secant. Now, when we have, for example, distance from this point to this point, like we have here, distance from this point to this point we have here, when we have an angle made between them, this point of this circle is called a sector. But if this circle is divided into four parts from the center, such that each part of this circle, right, makes an angle 90 degrees, then that part formed is called a quadrant. That's the difference between a quadrant and a sector. If you're not careful, you mistake them to be the same thing, but they're not the same thing. A quadrant makes an angle 90 degrees, while a sector makes an angle that is not 90 degrees when the two radii meet, like we'll see on the board. Okay, having said this, I want us to look at our app, the ExamGuide app. I recommend this app for you if you are really preparing for basic examination or you are in JSS classes. This app is meant for you to practice your questions, because the more you practice these questions, the more you master them and the more you become a guru in each of the topics. You may not know much about these topics until you have been tested. Okay, so let's look at some questions from what we've just discussed about lines and angles and circles. Let's look at some questions concerning that. All right, so let's look at this. This is 2015, paper 1. Let's look at questions. Okay, look at this. It said, which of the lines below is used for irregular boundaries? We have different types of lines here. We have a line that has zigzag. We have the short dashes here. We have the short dashes. We have the thin short dashes. Then we have the wavy line. I already told you in the course of this class that these wavy lines are used for irregular boundaries. That's what we use them to show boundaries between shapes or boundaries of shapes. We use wavy lines for that. So the right option here is option A. Let's look at other questions from this. Any angle that is less than 90 degrees is called complementary, obtuse, reflex, right angle, and acute angle. Like we mentioned, acute angle is an angle that is less than 90 degrees, but it is greater than 0. Please take note of that. 0 means no angle. Okay, so angle 1, for example, is an acute angle. Angle 89.9 is an acute angle. Okay, we have other questions here. See, which of these is a reflex angle? We have pictures from the question. Of course, we say reflex angle is an angle that is greater than 180 degrees, but not up to 360 degrees. That means it's less than 360 degrees. This is right angle here. This is an acute angle. This is an obtuse angle. This is straight line angle. Then option D here is the right option for that, which is acute angle. We have different questions here to attend to. Different questions to attend to. Look at this. The circle drawn below are, you see why I say it's important you practice questions. In the course of this class, we can have circles, drawn in circles. If these circles all have a uniform center, we say that such a circle is a concentric circle. Like the one we are seeing on this board, on the screen here, it's a typical example of a concentric circle because we see all of them have a uniform center regardless of the size of the circle. So such a circle is called a concentric circle. You see that? Okay, so this is the much we can take for now. Okay, till we meet again.